Okay, so we just finished part A of example 2, and we wrote the equation, and we found that our slope, or our variation constant, is 1/7, or 1/7. Okay, so m equals 1/7. So now we need to solve part B. Now part B tells us how much would a chunk of ice that weighs 3.5 pounds on Titan weigh on Earth. So we have a chunk of ice, and that chunk of ice weighs 3.5 pounds on Titan. Okay, so now we need to know how much does it weigh on Earth. So our formula now, we've calculated our formula because we figured out what m is. So our formula is now y equals 1/7 x. So now we need to decide where we plug in. So if we look at it and we go back to what we said our y was, our y is a weight of an object on Titan. And we have the weight of the object on Titan. We need to figure out the weight of the object on Earth, so we need to figure out our x. So based on that, we know that our y is 3.5 pounds, and that we need to plug in 3.5 for y. So I'm going to go ahead and plug that in right now. Okay, so then I have 3.5 equals 1/7 x. So now, just like before, we're going to once again solve that as a one-step equation. So we have 1/7 times x, so the opposite would be dividing. Now when we divide by a fraction, remember it's the same thing as multiplying by the reciprocal, or multiplying by the opposite. So I'm going to multiply by the opposite of 1/7, which is 7/1. That'll cross my 1/7 out. I'm going to multiply it up by it on this side. So we know since they're both over 1, it doesn't matter. I just have to do 3.5 times 7. Well, if I do 3.5 times 7, I'm going to set that up over here. Okay, 7 times 5 is what we're going to start with. And 7 times 5 is 35. So I'm going to put the 5 down. And I'm going to carry the 3. Then I'm going to do 7 times 3, which is, if you said 21, you're correct. Then I have to make sure and add my 3. So 21 plus 3 is 24. But wait, is my answer good just like this? Or is there something I forgot to do? If you said I forgot to add the decimal, you're correct. So I have to go back and add my decimal. Because I had one decimal place in my multiplication problem, I need one decimal place in my answer. So I'm going to count 1 and put my decimal place. That means our answer for this is x equals 24.5 pounds. Okay, so our object weighs 24.5 pounds on Earth. So I'm just going to write that at the bottom. So the chunk of ice weighs 24.5 pounds on Earth. Awesome, you guys are doing great so far. So I'm all out of room on this page, so I'm going to go ahead and turn to my next one. And we're going to do our final example, which would be example 3. Now, normally I would draw a chunking line, but once again, because I've turned a page, do I need to draw a chunking line? No, I don't. So I'm just going to set up my Cornell style. Remember, if you don't always put the line in, that's fine. Our notes don't necessarily have to look exactly the same. Whatever style works best for you is the style you should use. And if you need to pause or rewind this video at any time, go ahead and do so. So we're going to start our final example, which is example 3. Sorry guys, I write a little sideways and it throws off the camera some. Okay, I'm going to do our final example, which is example 3. Now, example 3 is going to compare different types of proportional relationships. Okay? So just like with our last one, it has an A and a B. And example 3 reads, the distance y in meters that a 4-person ski lift travels in x seconds is represented by the equation y equals 2.5x. The graph shows a distance that a 2-person ski lift travels. So for this one, we have to compare an equation to our graph that we have. So if your textbook isn't open, you will need to open up your textbook and make sure you're on this page to follow along for this problem. Okay, so make sure you're on page 161. So if we look, we know that y is our distance in meters. We know that because it comes directly from the problem. And our x is the time traveled. So it's time in seconds. Okay? And our equation for this is y equals 2.5x. Now they already gave us a graph that they want us to compare to. Okay, so I'm going to go ahead and draw our graph here. And they go up all the way to 12, and they're going up by 2, so 12, 10, 8, 6, 4, 2, 0. Okay. And they go over to 7. All right, they then go to 2, 4 as one of their points, and 6, 12 is another point. So then I'm going to use, once again, my nifty-difty little envelope paper because I don't have a ruler because I wasn't very prepared today, but that doesn't mean I can't do what I need to do. I'm going to use my tools and my resources to make sure I'm good. Okay, so this is the equation we're comparing. So we need to figure out what the slope is for this. Because right here, do we know the slope of our 4-person ski lift? Yeah. Our 4-person ski lift is our 2.5 slope. Now we need to figure out the slope for this. Well, we know that this point right here is 2, 4, because it tells us it on the graph. And this point is 6, 12. So we have to calculate the slope here. So we know that slope is rise over run. Okay. So we're going to count our rise first. So that's 1, 2, 3, 4. Sorry. So it's going to be 2, 4, 6, 8 is our rise. And then we have to do our run, which is 1, 2, 3, 4. So that's 8, 4. So our rise over run is 8 over 4. So now I have to see if I can simplify that. So take a second for me and simplify it. If you answered 2 over 1, then you simplified it correctly. So our slope for our 2-person ski lift is 2. So now if we compare our 2 ski lifts, we can draw a conclusion based off that. So once again, this is our 4-person. This is our 2-person. Okay? Now if we're comparing, I would say that 2.5 is greater than 2. So that tells me that the 4-person ski lift moves faster than the 2-person ski lift. All right, that's awesome. So that's part A to this question, and then let's move on to part B. So part B says, graph the equation that represents the 4-person ski lift in the same coordinate plane as the 2-person ski lift. Compare the steepness of the graph. What does this mean in the context of the problem? So to graph it, I'm going to set up my XY input-output chart, but I don't have to. If you're comfortable just graphing based off this, you can, but I'm going to use my XY input-output chart just because. So I'm going to use 1, 2, and 3, and it'll give me some of the points. I actually might go all the way out and just jump ahead to and also do 0.6. So I'm going to plug in 2.5 times 1, I know is 2.5, right? So then 2.5 times 2, well, 2 times 5 is 10, carry the 1, that's 5. Then 2.5 times 3, if I multiply it out, I get, take a moment, 7.5. And last but not least, 2.5 times 6, multiply it out, it's going to be 30, carry the 3, 6 times 2 is 12, so that's 15. Okay, so now I can plot my points. I'm going to go ahead and plot it in a different color to make it stand out. So I have 1, 2.5, so it's going to be like right here. Then I have 2, 5, 5 is halfway in between 4 and 6. Then 3, 7.5, like right here. And 6, all the way up here, is way up at 15. So that's going to be like way, so that's 14 there. It's going to be like over here, so it's going to go a little bit into my words up there. But that gives me a good amount of points to set where my line is going. So I'm going to connect it to 0 and slope it up. And so that's kind of where my line is going. And if I look, I can see that my line right here for the 4-person one is much steeper than my line for my 2-person. So this is the 4-person, and this is the 2-person. And I can see my line is much steeper, so that means it goes faster, and that it'll save me time. All right, so that covers direct variation for us. Hopefully you understand it pretty well. We'll do some practice problems in class when we go over the notes. Thank you so much for listening, and remember, if you need to go back or re-listen, you may do so at any time. Have a good day, guys.